Welcome to this DQOA repair video. This morning we're going to repair electric motor fan on a Coldzone Glycol unit. You can get a big shot here. I'm on my roof, and this right here is my Coldzone Glycol unit that cools my soft serve machine. It's a closed loop cooling system. It's one of the more common closed loop cooling systems in the system. As you can see, it has two fans on top. This machine has a two-stage fan system. Right now, this fan is the one that's working, and I have that as my lower end primary fan, and this is my secondary fan. And right now it's locked up. Now, in order to see, when I flip this, you can see that this motor is locked tight. When I spin the fan like this loosely, the fan should make at least 3 or 4 revolutions without much resistance, but as you can see, I push it. It's locked completely tight. So that's most of the time how you can tell if a fan motor is bad and when it locks tight, because it should swing freely when the unit is off. Just so you know, the tools you're going to need to do this repair is you're going to need quite a few tools. The first thing is you're going to need a 8mm socket, and that's what I have right here. And the 8mm socket is for taking the bolts off the cage on the fan. And we've already taken the cage off on this one already this morning. The other tools that you're going to need for this is you're going to need a vice grip. That's this tool right here. You're going to need a flathead screwdriver. You're going to need a Phillips head screwdriver. You're going to need a wire cutters, and you're going to need a 1/2-inch wrench. And instead of a vice grip, you could get away with having 2 1/2-inch wrenches. Instead of 2 1/2-inch wrenches, we're going to use a vice grip. And then you're also possibly going to need some number 1 wire nuts. We're not going to need those because we're just going to reuse the ones that we have on this equipment. This is the second time I've replaced this fan motor in the life of this equipment. This unit is 17 years old now, and it's done well for me. And what it does is it cools my soft serve machines downstairs. It saves about $10,000 a year in water bill, and but one of the drawbacks of saving $10,000 a year in water bill, it requires a lot of maintenance. So alright, what we're going to do this morning, because it's 30 degrees out here, my fan isn't running, all it's doing is pumping right now. What you have to do first is shut your soft serve machines off downstairs. You need to flip all the soft serve machines that you have on this unit to off, or they're going to trip on high limit reset when you shut this unit off. So what we're going to do now is we're going to shut the unit off, and there's a disconnect box right here. And all you do is flip the thing down, and you can hear that the motor is stopped. Now, if you don't have your disconnect connected up here, which you should, you can also flip it off at the breaker box, and make sure the power is off when you do this repair. So we're going to get started here this morning, and I'm going to have my helper employee here, William, who's very mechanically inclined and is able to do almost any repair in the store with my guidance. He's going to take the fan off. We have 3 Phillips head screws that are on the axis on this shaft. Now, just so you know, this is a retrofitting. The last time I replaced the motor, the original Glycol fans come with like a sleeve that have like an Allen wrench clamp to the fan motor axis, and those things are impossible to get off. If you have the original motor in your units and you have that collar sleeve on there that's part of the fan itself, I recommend not even bothering getting that off. Just get the retrofit, and you can see the fan comes right off, and it has this access here. And what we're going to need to do is we're going to start pulling the motor off. Now, this is the retrofit access part, and I'll have the part numbers for this fan blade and this retrofit access. I recommend you buy these 2 pieces because I bought this last time, and these come off relatively easy. We're going to need an Allen wrench to get this out, but we don't have to do that right now. I'm going to have Will start taking the motor mount out. What we're going to do is we're going to put the vice grips on the first. We have two screws here that mount the motor in place or hold the motor in place. And what he's going to do is he's going to clamp the vice grips to the one end here. Got it? Okay. There we go. And then he's going to take the 1/2-inch wrench, and he's going to start unscrewing the mount. And I think it goes the other way. I think that's making it tighter. Go the other way. start from the bottom, work your way up. So he's gonna take those two bolts out. There's one on top and one on the bottom. And what I'm going to do is I'm just going to pause the video. We'll get that out as to not extend time on the video. And when we get that out, we'll resume the video. And we're back. We went downstairs and got an Allen wrench. We couldn't seem to find the right Allen wrench, but we ended up putting a T25 star drive in there to get this access collar off. And you can stop right there. And then there's one right here that we need to get. So there's two flat edges on these fan motor mounts, and this fan collar is held on by two different by two different things, and we use the T25 star drive, and we're gonna see if we can get this thing to get loose here. There we go, we got it a little bit loose. Now that should be good. It's loose, isn't it? There, yeah, we got it to move. So we'll pull the motor out first and then pull it off. But just so you know what a star drive is, it's sort of like an Allen wrench, only it has like a Phillips head type deal on it. You know, I don't know if you can see it on the video, but it's a little bit like an Allen wrench, but it's a star drive. So it's a T25 star drive for those collars. What we're going to do then is, you can see we have the mount bolts out here. What we're going to do is we're going to pry the mount apart with this Phillips or a flathead screwdriver here, and see if we can get some expansion here. And while I'm doing this, what we're going to do, hopefully we'll see if Will can pull the motor out. I'm going to try and see if I can get this collar to expand out. There you go. Usually you want to use a heavier duty or screwdriver to get a wedge in there. All right, what he's going to do then is he's just going to set the motor or lay the motor right there. And what we're going to do is, just so you're aware that this motor, this is a 208 210 5-wire motor, and we're going to disconnect it here. This looks like a jumble of mess here, but it's really not too bad once we get all this out here. Now what we're going to do is we're going to pause the video again after we get in here. And now below here in this unit, below this shaft here in the corner is the capacitor. And what we're going to do is we're going to pull this shield out here and bring this capacitor out. We're going to replace this capacitor while we're here. It's always a good idea to do that. Most of the capacitors come with the motor, and in this case it did. So what we're going to do is we're going to pause the video. We're going to pull this out, and then before we take the wiring apart, we'll start the video again. There's on top of the unit, there's two bolts right here that hold that shield in. That's these two bolts right here, and you can get those out with a flathead screwdriver. All right, and we're back. Now, I took this plate out. This is my old start capacitor in this unit here. And now, if you can see in the corner here, these are the two lead wires coming from the main unit electrical box. And one of these wires runs to the capacitor, which is right here. This is the wire coming from here. The other wire is tied directly to the motor, which is this one right here. This one runs right to the motor. It's just wire nutted together. And the other two wires on this capacitor are coming from the motor. Now, if you can see this. All right, we've pulled this capacitor out, and I'm going as you can see, the two wires, I got one of the connection, the other one pulled out here. That's just a hard wire that was in my wire nut. So you can see I got this completely pulled out here. And what this looks like this when you have this all pulled out here, when you got the motor capacitor pulled out. And in looking at this, because of my mount, I think I'm going to keep the old capacitor. There's nothing wrong with it as far as I know, and it's a bigger capacitor than the one they sent with the motor. So I'm thinking about just keeping this old capacitor for now, just for the ease of this video. And what we have here is, this is where the motor or the main line was connected on this side, and we have a white white extension going to this side, and then here we have the brown wire on the old motor going on to the other side of the capacitor. So what we're going to do is we're going to disconnect all this wiring from this capacitor, weave it through here, get all this wiring out of here. This is the wiring from the old motor, and we're going to dispose of this old motor. And now, don't throw this motor away. This motor has scrap value. This old motor, you can take it as is to the scrap yard and you can get 20 to 30 cents a pound for old electrical motors like this. And you can also disconnect all this wiring or cut this wiring from the motor and send this wiring in separately. The wiring like this at the scrap yard gets 60 cents to $1 a pound, depending upon market conditions. So it's good to disconnect all this wiring from your old motor and just put it in a separate vat to take to the scrap yard. So we're going to do that, and we're going to put the new motor wiring, feed the new wiring in here. Before we connect the wiring, we'll start the video up again. Thank you. All right, and we're back. All right, so we got this motor sort of sitting in a mount here. We're trying to get the wiring configuration hooked up here. We have quite a few wires on this motor. There's actually a lot of extra wires. I got a 3/4 horsepower motor on this, and I'll talk about that in the comments below the video here. These are the motor spec configurations in case you want to see them before you having to go up to the units to look at them. But now this has a complex wiring diagram here. This motor has instructions on it and has a clip on it here, and it's important to look at. If you can see this wiring diagram, the line here, there's a high, medium, low, and low setting. You put that color wire for what we want to do the high setting, the black line here. So basically the blue, yellow, and red we're going to cap off, which is what we've done here. We're just going to cap those off because we're not using the blue, yellow, and red wire coming from the motor. However, if you're in a situation where you don't want it to be flapping so high, we want the high setting here for this. And then if you can see on this diagram, the brown and the brown-white goes to the capacitor. Now in this instance, since we have a 2-line coming in here, the brown-white wire we're also just going to cap off because we're not using that. Now on my previous motor that I pulled out here, we also had the brown-white wire capped off. So you can see here we got 4 wires that are capped off or terminated that go to nowhere. So we're going to put electrical tape on those and just bind those together with the cap off on it. Now the other two wires coming from the motor, the white one is going to go on this side of the capacitor, and we had to keep this capacitor because this motor requires a 10 MFD capacitor. The one that they sent in the box is 7.5 MFD maximum, so that's why we have to retain this capacitor. So it's always good to look at the motor spec configuration to make sure that you have the right thing. And as you can see here, we're looking at a 3/4 horsepower motor on the spec sheet here, and it says it has to have a 10 MFD capacitor. So that's one of the reasons why we got to retain the old capacitor here, because they sent us a smaller capacitor. But what we're doing from the motor here, we're feeding this thing through the other side. We're feeding the wires to the other side. And you want to put the white one on this side of the capacitor and the brown wire on the other side of the capacitor. And then when we connect the 2 main lines, what we're going to do is connect one of the main lines to this side here with the nice little end on it to this capacitor where the other one was, as I showed you when I pulled it out. And then we have the other black wire coming from the motor here that we stripped out. And we stripped this thing out, and you can see right here, I got it stripped out. And I fed it through the coil down on the other side here because this capacitor will be flipped up and face inward towards the machine. So what we're going to do is we fed this wire through here, and then when we get this thing down here is we're going to wire nut this together. But since I have such a long line run, we're just going to wire nut this together right here while Bill holds the phone. And we're going to get the other lead of this capacitor. I don't know if I have it in the right position. So, you got it in the right position? Okay, so what we're going to do is we're just going to wire nut this together. See, we stripped this wire with our wire cutters already coming from the motor. We clipped the end off that came with it, the nice neat end that came with it. And what we're going to do is just wire nut this back on so it's nice and tight like that. So we have one lead connected to the Glycol equipment. And then what we're going to do is we're going to grab the other lead that goes on the capacitor, which is right here. And unfortunately, since this is such a short line run in here, we're going to have to get this down in here like this. We're going to have to... Are we recording again? We're going to set this down in here. And this one goes with the white wire here, so we got to put it on this side of the capacitor with the white wire. If you remember, we took the white wire off of that side with this lead, and I apologize if my hand's in the way on this, but basically we're just going to slide this right on to that side of the capacitor with the white on the side with the white wire. And sometimes, you know, getting down in there is not such an easy thing. There we go, we got it in there. All right, so what we have here again is we have this wire is connected directly to the motor by wire nuts. This is the one lead wire going there, and then the other lead wire is coming into the capacitor on this side, and then the motor, there's a white motor wire on this side of the capacitor with the lead wire on the capacitor, and then there's the brown wire that is coming from the motor on the other side of the capacitor. So basically we have this all together. We're going to pause the video for right now. What we're going to do is we're going to take some electrical tape or some, shall we say, zip ties. We're going to bind this wiring together so it's not hanging down in the air fins here. And then we're going to put this, we're going to basically mount this, we're going to put this back up. You see the screws go through here. We're going to put this back up here and mount these screws to the top again, so this is back on there in the corner. And when we come back, we'll show you how to put the motor into the mount now that we have it all wired together. Okay, and we're back. As you can see, we have the plate mounted in there, and we are getting ready to put the motor in the mount. Now, on this, you're going to have to make sure that the wiring configuration coming out of the motor here, you have to put it down into the mount where the bolts go, so you can get it down there. And then you got to be careful of this ground wire, that you sort of got to arc it this way to get that ground wire into the mount. And then you're going to have to shimmy it to make sure all these wires get through. And again, the bottom rung, you got to get the ground wire through. So this is how you get the wiring all the way down in there and get the motor to sit down in there into the collar like you see here. Now what we're going to do is, you can see all this wiring is connected to the unit, and you can see we have all this excess wiring here. We're gonna take some electrical tape and just bound up this wiring in here really nicely so it doesn't get caught or sucked into the fan. And we're also going to put the mount brackets and the mount bolts back in here. And now when you put the mount bolts back in here, make sure the ground wire on the motor goes onto one of those bolts or inside one of the bolts on the mount bracket. And that's what we're going to do right now. We're going to pause the video to do that, and we're going to have all this wiring taped up and everything, and then get the mount brackets. So then when we come back, we'll have this thing mounted in place, and then we'll put the fan access and the fan blade back on and test it when we come back. Thank you. All right, we're back again, and as you can see, we got our electrical all taped to the mount here. And you know, you don't have to use electrical tape. You can use plastic zip ties if you want to, but electrical tape's just as fine in my opinion. But as you can see, we got the mount bracket bolts back on. The ground wire for this was a little bit thin and didn't go through the bolts, so we just pinched it into the bolts to ground it right here. And so we got the bracket on. As you can see, the motor's in there tight, and what we're going to do is we're going to put the fan access mounts back on there, and with our T25 star drive, and then we're gonna bolt in the fan, and then we're just gonna put the cover on and give it a test run. So we'll be back when we're ready for the test run. We're back, and we got the access collar on there, we got the fan blade on there. Now as you can see, when we spin it, that's how a fan blade should spin when the unit is off. If you remember at the beginning of this video, it didn't spin at all because the motor was locked tight. We're just going to set the cage on there for right now, and we're going to give this thing a test run and see where we are on it. And what we're going to do is we're going to go into our box here that's next to the disconnect and open the bolt up at the bottom, take the cover off like this. And we're going to show you the thermostat gauges on here. This is the thermostat gauge for the fan that it was working. And if you can see the gauge down there, there's a you know, it's set at 55 degrees. And then this other one was the gauge for the fan that doesn't work. I set it to a way high level because it was a 30-degree week, and the fan motor was burnt out. I set it to way high level so it wouldn't activate or run while it was burnt out. So we're going to flip this unit back on, and you can hear the pump is back on. And then what we're going to do is the fan that we were working on, we're going to turn the dial down to about 40 degrees and see if it kicks in. And as you can see, it just kicked in. That's the fan that we were working on over there. And I just want to show you that the difference. We put in a 3/4 horsepower motor, and I don't know if you can hear the rumble of that. We're going to turn the other fan on as well here by turning the other dial down. And we're going to turn this dial down a little lower to turn this one on. And you can hear the difference. This is a 1/2 horsepower motor in here. And as you can see, this one's, I don't know if you can see it on video, this one's not spinning quite as fast as the one over there. So when you're looking at replacing motors, it's probably a good idea to put a 3/4 horsepower back in. And I don't know, Bill, are they spinning in the same direction? Yeah, they're spinning in the same direction, aren't they? Is the air's flowing up? Yeah, the big thing is make sure that your fan blades are spinning in the right direction. You want to make sure the air is coming out the top of the unit, it's blowing out the top. And if your air is sucking into the unit, that means you got to flip this fan direction around by inverting the wires. So basically you want to make sure the air is coming from the bottom of the unit, coming underneath the bottom of the unit like right here, and then flowing up the top like that. So as you can see, we have both fans are running. You can see the 3/4 horsepower fan motor is definitely getting more air relief over there. So when this fan motor goes, I'm going to put a 3/4 horsepower into this one because my 1/2 horsepower just have been a little weak when it gets to be like 85 degrees outside. So I'm hopeful the 3/4 horse will be a much better fit for this unit. So we're going to set these dials back to where they should be. I'm going to set the one that we replaced, I'm going to set that one to about a 55 setting. And we're going to set the secondary one, the one that was working in my 1/2 horsepower, we're going to set that one to 70 degrees. So what happens is, when the fluid gets to 55 degrees or higher in this unit from machine use downstairs, that fan will kick in and run on its own. And if the fluid, just on that fan running on its own, the new one that we put in, if the fluid gets to 70 degrees, then this fan is going to kick in and cool this system as well. So basically it's a two-stage system. So what we're going to do is we're always going to set the new fan as the primary, which is what we've done right here, and this is my secondary kick in. We're actually going to set this to 65. I think 70 may be a little high. So we're going to keep those dials right there. So that we're going to seal all this up, and we're going to put the bolts back in the mount up here, and then we're going downstairs and turn our soft serve machines back on. And if you have any questions about this video, I'll leave my contact information at the bottom. Thank you.